All right, here we go. We got one more here we're going to look at. Student fires cannonball vertically upward, and the cannonball returns to the ground after an 8-second flight. Determine all the unknowns and answer the following questions. Neglect drag and the initial height and horizontal motion of the cannonball. So using a regular metric measurement, we're using meters and meters per second, etc. Okay, so let's see here. Let's get going. So first of all, I like to start with writing a list. Student fires a cannonball vertically upwards. Cannonball returns to the ground after an 8-second flight. So time equals 8 seconds. Now, FYI, whatever time it takes, if it goes all the way up and all the way down, half of that time is the up. Time over 2 is the down. So it takes 4 seconds to get to here. All right, so we're going to get to that in just a minute. Determine all the unknowns and answer the following questions. Neglect drag and the initial blah, blah, blah. Okay, so what else do we know? Acceleration is negative 8.1. Oh, I'm sorry, so negative 9.81. Duh, I don't know where I'm going with that. Negative 9.81 meters per second squared, and that is acceleration due to gravity. Okay, so G. And the first thing is how long did the cannonball rise? And we know it's going to be approximately, 4 seconds. Half of the full time. And if the full time is 8, take half of that, it's 4. So what was the cannonball's initial speed? Now we're just talking. So V initial is question mark. What is V final on the rise on the up? What is V final here? V final on the way up. So vertical V final equals just for the rise. All right, so we're not considering what happens after it gets here, but for V final on the way up, for this half the time, V final is 0 meters per second. So it goes to the top, it stops, and then we know it stops because it changes direction, starts heading back down under the same acceleration the whole time, constant acceleration of G. So V initial is question mark. V final for the rise is equal to 0 meters per second. And so we have a formula for this. A equals V final minus V initial divided by T. So V final is 0. So this whole thing goes away. V initial is, what do we say? Oh, that's our question mark. And then AT. If we multiply both sides by T, T's cancel here, and then we can just slide that in there. So AT equals V initial. Now notice this negative sign here, negative V initial. I'm underlining there. I probably should get rid of that underlining scribble. Looks like an equal sign. So this negative sign that we're pointing at goes with V initial is negative. And G, which is our acceleration, is also negative. So we have a negative here and a negative here, so those can cancel out. So we can just ignore those. They go back to positive. So 9.81 times 4 seconds is equal to, give me 1 second here, 9.81 times 4. Whoa. 9.81 times 4 equals 39.24. 39.24 what? So this is meters per second squared. And this is seconds. So one of these cancels with one of those. So 39.24 meters per second. 39.24 meters per second. So our V initial is 39.24. And again, meters per second. And then what was the cannonball's maximum height? Well, the height that it goes up here, we can consider a couple things. We can consider V initial as that. V final is negative that, right? So V final for the launch all the way up and all the way down, if V initial is 39, so this is 39.24, then V final is negative 39.24, because that's what slowed it down on the way up is the same thing that speeds it up on the way down. And remember, it's half the time on the way up, the same amount of time on the way down. So that what slowed it down is the same thing that speeds it up. So those velocities are going to be equal but opposite. So you can do a couple different things. You could say, okay, let's just consider the drop. That makes this a lot easier because maximum height, we could say change in height is equal to 1/2 gt squared plus v initial t, and I'm just going to put plus height initial, and then we're going to put height final. So this is 0. 0 equals, instead of change in height, we're going to kind of ignore that for a moment. 1/2 gt squared, negative 4.9. And if we just consider the fall, if we consider just the drop, that means V initial is 0 meters per second. Okay, so this whole thing goes to 0, and then height initial is our question mark. So 0 equals negative 4.9 times t squared plus height initial. Well, subtract height initial from both sides. So negative height initial equals negative 4.9 t squared. Well, for us, t is 4, and we have negative on both sides, so those go away. So height initial is 4.9 times 4 squared. So 16 times 5, it's about 80. 16 times 4.9 is 78.4 meters. So the height maximum is equal to height initial for just a drop, and that's equal to 79.4 meters. 79.4 meters. So there you have it.